Hmm. Thanks everyone for joining us today. We go to jump to the next slide, Nicholas. There we go. Yep, so I'm Chris Mounts. I manage a large group here at PMC that does all of our reality capture, CAD, and BIM services. And then today, Nicholas is joining us, and he is our lead for pedestrian simulation here at PMC. This is part of a whole series of learning things we do for AIA credits, uh, different ones in different months that come out. This one is actually a new one for us and our first time doing it. So excited to present with you all today. Next. Yep. So today we're just going to go over a few things. We're going to start with a real brief introduction to who PMC is, and then we'll get right into the heart of it today with the simulation and crowd simulation, the tools that are used, some showcases showing you actual projects, and then we'll wrap up with some Q&A. So we've been around here at PMC for a very long time. 1979 we were founded. And we were actually founded as a simulation company. Back in those days, simulation was mostly on the manufacturing and industrial side. It's only been in the last maybe decade or so that we see it moving more into the AEC side of the business. Um, my part of it is obviously scanning and modeling buildings and doing all kinds of CAD support, but we've always done simulation dating back to 1979 with some of the earliest simulations out there. Hey, next. Um, a quick overview of all the different things we do here at PMC. Any of these are interesting to you, you can get a hold of us offline and we can talk more about any of these items. So real quick, like I said, my part of this is a scanning CAD and scanning services. If any of you have joined us on the other webinars we do around this, they all focus on scanning and CAD services. One of the largest providers of that in the world. We can move on. Next. And with that, I'll hand it over to Nicholas to talk about why starting with why simulate things. And over to you, Nicholas.
Thank you, Chris. So we're going to start things off by asking first, what is simulation? So simulation is the art and science of creating a representation of a process or system for the purpose of experimentation and evaluation. That can be done physically, but in our case, we're doing this in software. And practically, simulation lets you test drive your layout, process, or organization before you build it or modify it. So now we'll move on to why. So why should you use simulation? Well, firstly, simulation helps with prediction. Simulation allows you to investigate how changes in any number of factors can influence the outcome of a scenario. So for example, if the specified widths of a stadium's entrances will be enough to accommodate a crowd, coming in and coming out. Next, simulation enhances safety and security. So for example, identifying the adequate quantity or placement of emergency exits in a venue. Simulation makes it easy to test alternatives and perform what-if analyses. So we could test natural disasters, shelter-in-place scenarios, or repurposing a structure after you've done a model to begin with. You can do that in addition. Simulation helps us optimize the movement of people by foot and other forms of transportation. Next, simulation is a powerful communication aid. With a simulation model, you can see the scenario play out in real time. This one helps you make sense of the data, but it also helps you communicate it with others. And then lastly, simulation saves on time and cost. We're able to test proposals before the real world implementation. And we all know that doing things virtually is far less expensive. So when should you choose to simulate? That brings us to when. So we should use simulation when we're dealing with any stochastic process or kind of randomness. We should use it when conventional analytical approaches are not suitable. So for example, when a system is too dynamic or complex to do calculations on paper or in Excel. and then when real life experiments are not an option. So this can be because the system doesn't exist, like in a design phase of a building, or if they're just high risks, cost and time needed. Simulation is also a fantastic option in those scenarios. So then lastly, how do we simulate pedestrians? Well, we can use pedestrian dynamics by control. That's been our choice as long as we've been doing pedestrian simulation. In pedestrian dynamics, or PD for short, and I might switch between the two, each pedestrian is represented individually. So these pedestrians can see, plan their routes autonomously, and interact with each other and the physical world around them. The software shows the interaction between pedestrians, their environment, and then infrastructure and services all in real time. So that brings us now to our next section, where we'll go over some of the inputs and outputs of a crowd simulation study. So to start off, we'll kind of do a little bit of a tangent. We're starting where the societal trends that we have been observing. So we all live in a rapidly growing world. Our cities are attracting more and more people, and their physical space remains limited. So in the future and now, stimulating active mobility and efficient land use is going to be crucial. And with the right tools and practices, we can prepare and build smarter. So what are some of the challenges that we face when planning for crowds? First challenge is ensuring crowd safety while allowing them to enjoy themselves. So for example, maximizing viewer satisfaction at a concert while getting them in and out safely, preventing crushes, stampedes, things like that. Another challenge is incentivizing active mobility. This requires effective policy planning. So if pedestrians feel comfortable and safe, or if cyclists can easily park their bikes near their destination, the likelihood of using these modes of transport increases. Next, capacity planning is also crucial when building new pedestrian infrastructure, or in fact, when repurposing existing spaces. So for example, if you're managing extra crowds in a stadium, so when you're having it for like a concert as opposed to just a normal game, you have to ensure that all pedestrians can be sheltered in the event of bad weather, for example. And then lastly, understanding the behavior of active mobility users is a significant challenge. And despite growing academic research in this field, much remains unknown, and some of it is difficult to assess. So trying to match the behavior of people, that is always a challenge that we're facing. So to a large extent, simulation provides useful insights to address all of these challenges. And so that brings us now to the crowd simulation timeline. We like to say that there are effectively 4 major steps to analyze a crowded environment through simulation and to answer key questions about things like its safety and its operation. So we start with the environment. When drawing up or importing an infrastructure from CAD or BIM, one needs to define, for example, the width of paths, locations of crossings and other interaction points, and the location of critical elements such as stairs, escalators, elevators, etc. Data is key when we're developing a simulation model. The quality of what you put in is directly related to the quality of what you get from it. The saying goes, garbage in, garbage out. Regarding the population, we need to answer the questions of who's there, when they're arriving, where they're going, and in what order. But we must also ask, what are these activities they're going to? Where are they located in the greater environment? And how much time a visitor is going to spend there. For example, what's the duration of a concert? How long does it take to get concessions there? And where are those concessions being sold? All this information gets input into the software, and therefore it all interacts with each other. The arrival pattern of visitors and the activities they're likely to perform when they arrive, for example, getting their ticket scanned, can then lead to how long the queues may be and just how they behave in general. When the simulations run, the interactions of these pedestrians and their environment will highlight potential bottlenecks and provide indications of which crowd management strategies may be necessary. These results ultimately are going to help event managers, infrastructure operators, and designers make better informed decisions for crowd safety. For each of the steps that we've just presented, Pedestrian Dynamics provides users with tools which facilitate and guide this model building process and its analysis. So firstly, it's a microscopic crowd simulation software. in which each pedestrian is modeled as an individual with their own characteristics, such as their speed, size, route preferences, their field of view, how far they're able to see. So large crowds are then formed by these diverse set of individuals, and they all interact with each other in a multi-layer environment. And complex environments can be easily built. You can build them by hand or by importing a CAD or BIM model. So this makes the model building process much faster, and it makes it a lot more accurate. Analysis is facilitated by the multiple quantitative outputs that are directly obtained in the software run. So things like crowd densities, throughput, and wait and travel times. And we'll go a little bit more in depth with this in the next slide. Pedestrian Dynamics provides a 2D and 3D visualization, so you're able to watch everyone move in real time. And as previously said, this is a powerful communication tool, which it's really invaluable in discussions with clients and stakeholders and just verifying that everything's running correctly. So the software itself has been developed in close cooperation with academia. It's validated and verified accordingly to international guidelines, and this gives assurance in the results and the analysis performed with it. So what are some of the outputs we can expect from PD? First, we have a 2D and 3D visual. This is a 3D screenshot. PD gives us density heat maps. So here we can see where bottlenecks and other high density areas are. So you can see the red going on there. We can get travel time maps where one can see where the starting points for visitors corresponded to longer travel times to their destination. This gets used a lot during evacuation scenarios. We get graphs which summarize travel time and all these other statistics such as queuing time, queue lengths. So there will be graphs to go along with the heat maps, for example. We're able to place flow counters at key areas. And so that'll just show us the foot traffic through a corridor, for example. And so shown here is a sample output of that. And we can also see the level of service at specific areas where the duration of high densities can be observed. So this is kind of a density map, but over time. Besides these, there's a lot of other statistics that can be obtained from the simulation or created custom by the user. So this allows you to define your own KPIs for your analysis and business goals, whatever they may be. And so that brings us to the examples. We're just going to show you a few examples of models using pedestrian dynamics and some of the questions that we were kind of asking and answering with this with these models. So this video shows a simulation of a major stadium with a capacity of over 60,000 people. In this study, the key questions pertain to the structure's capacity and how its design could be improved to handle full occupancy. Also of interest were ways to manage ingress and egress during peak events. A simulation like this allows for the testing of the layout in its early stages to identify potential problems before construction commences, which naturally reduces building and renovation costs. It also helps site managers plan for the needed quantity and placement of security gates, along with measures to distribute people over the different entrances in such a fashion that minimizes the queues, thus increasing patron satisfaction. And during communication with stakeholders, a real-time simulation playback like this helps prompt, additional questions and inform answers. So when studying stadiums, it's also important to keep in mind that they don't exist in a bubble like we see here. That same crowd of 60,000 people is eventually going to have to file out into the surrounding area. Now in this video, we see a model of the same stadium, which was then expanded to include neighboring streets and multiple forms of transport. So we see pedestrians, cars, trams, bicycles, all simulated and interacting with each other. This helped identify the necessary crowd management measures to not only guide visitors smoothly in and out of the stadium, but to also optimize their usage of the available transit capacity. Simulation does not only, however, provide useful insights when managing large and crowded environments, it's also fantastic for things that are a bit more close quarters. So shown here are two alternative layouts of a casino. This is another kind of egress scenario. In pedestrian dynamics, multiple layout options can be tested and the what-if conditions analyzed. This video shows people evacuating from their gaming locations to 3 exits. Both scenarios have the same selection and quantity of games, but they're arrayed differently. In smaller scale environments with many obstacles, like in a casino here, simulation can also provide answers to questions such as which layout is more efficient and ultimately safer during an evacuation. We saw here a density overlay. That's, again, fantastic feature that PD has. This is showing us graphically where the crowding is occurring in different layouts, and it does help us inform which layout is superior. The results also showed us which layout had the fastest evacuation time, so you kind of have 2 angles to look at it from when evaluating these 2 layouts. So next up, we'll show you how simulation contributes to operational planning and user experience. In this video, we see several tour groups proceeding through an exhibition. Here, visitors had a guided journey through an environment with specific activities in each room they visited. Having a final infrastructure design, like in this case, with all the planned elements and obstacles in place, doesn't necessarily limit the need for simulation, as capacity planning is also dependent on the activities performed. So in this study, we asked, for example, what is the maximum group size that this experience can support, and which step in a visitor's journey through it is going to be the bottleneck? That is the step that effectively defines its capacity. Identifying such capacity also raises the question of if the time spent at other areas should be adjusted to facilitate a smoother flow through the environment. So, for example, having people spend a longer amount of time to wait for the bottleneck to clear out. So PED's outputs helped maximize the level of service provided, thus contributing to user satisfaction overall. Now, in some studies, we may also ask how an environment can be repurposed, like here. A city environment that works for daily commuting might present challenges to manage when street gatherings or events occur. So here we ask, how can we effectively operate within an existing environment like the city center shown here, considering different route usages, or when adding things like food trucks and blocking off streets for first responders? How many visitors can we comfortably accommodate in this event? So, like we said, we want to make the most out of this existing environment. This is an older city center, and work around existing constraints like the width of streets, spacing of streets, etc. A simulation like this helps us identify the best placement for cameras or security personnel, so to monitor crowds in key locations. It also helps us define and test crowd management strategies, such as restricting flow in one direction or blocking off certain alleys. And ultimately, it aids in training hosts, security, and hospitality personnel. The animation you see here offers visual support with the crowd control groups and to provide stakeholders with feedback. It's a very powerful communication tool, what you see here. We always want to be safe during these events, but of course there's going to be things that we can't predict, but still simulation can help us be prepared. So we all remember COVID, all the regulations that came with it. Another great benefit of this software is that we're very quickly able to implement new features. We can modify things with it. So in this video, we see a social distancing feature that this was added during the pandemic to simulate physical distance. This helped plan for the implementation of the 6-foot social distancing and in finding any new bottlenecks. That is, in this case, the locations in a pedestrian's journey where the social distance was most often violated. So using Pedestrian Dynamics, venues were able to safely reopen again, and sometimes with completely different purposes, such as a vaccination and COVID testing facility. And this gave them the opportunity to contribute during the pandemic. That kind of brings us towards the end, toward the wrap up. So in summary, the simulation tools and features shown here today, one, they improve the decision-making process. And that's by sharing results and insights about complex and unpredictable processes. And this is done through providing relevant information, graphs, dashboards, and testing scenarios. With PD, we can optimize business processes, so identifying waste and deficiencies when streamlining and integrating. and we can contribute to one-time right solutions and deployment. That is, with pedestrian simulation, we can test proposals before they're ever deployed in real life, and this all helps in reducing time, effort, and costs. Third, the simulation tools offer support from design to operations, so we're able to simulate during the design, build, test, and maintenance stages. And indeed, we've done simulations where the building has been redesigned multiple times over, and the turnaround to then update that simulation is very short. The simulation results can present relevant what-if information, and that itself can influence design decisions. And then lastly, crowd simulation can improve safety and security. So it's going to impact our analyses and help advise and train personnel and create and improve procedures. And that wraps everything up. We at PMC would like to thank all of you for joining us today, and we'll now move on to some questions and answers that you may have. Thank you.
Thanks, Nicholas. Please remember, if you have any questions right now, please submit them via the Q&A feature, but we did receive some already. First off, how specific can you get with simulating people like the elderly and disabled?
So we can get very specific. In the software, the pedestrians have certain characteristics that will impact how they route themselves and interact with their environment. So things like their radius. So an increased radius might be able to represent something like them having a mobility scooter, their speed, their vision, and then there are also just general route preference options that you can tick. So elderly people might be more likely to avoid stairs. They might prefer escalators or elevators. These are all essentially variables that are inherent to the software and come with it right out of the box that you're able to tweak and to the point where you get that the behavior that you're trying to see.
Thank you. What is the software of simulator you use?
So the software we use is called Pedestrian Dynamics. It's made by In Control, which is a Dutch company, and that's the only pedestrian simulation software we use.
Okay. And we're in direct partnership with them and can facilitate a conversation if necessary. No problem. Next question I have is that you mentioned testing different configurations like blocking off or restricting certain streets. Would that require making changes to the CAD drawing and importing it again?
So that would not. When you import from CAD, that gets brought in as objects that exist within the software itself. So they're brought in as just walls that the software is able to interpret. And then after the fact, you can then edit those however you please, block off doorways, and just do all of that natively within the software, and even put in controls that will, for example, open a doorway in one scenario or close it in another. So you're able to test things basically in parallel. So it becomes very quick once you've done that first import. You don't really have to do anything that laborious after the fact. Small tweaks you can do very easily.
Hey, thank you, Nicholas. Got another one for you here. If you are to do a pedestrian simulation on an existing facility, do you first have to scan the building? Also, do you put up people counters to get the variations in people flow throughout the day? Can you pinpoint the amount of pedestrians past a specific space?
Yeah, so you don't necessarily need to scan it. If you have architectural drawings, you can import those. It doesn't need to necessarily be a 3D file. You can, go just off of floor plans. And indeed, you're able to interact to an extent with, something like a DWG file within the software itself. So you don't have to, go into AutoCAD and turn off a layer. If you don't want it to be imported, you can turn off those layers within Pedestrian Dynamics itself, which is very convenient. And sorry, what was the second part of the question?
Can you pinpoint the amount of pedestrians past a specific space?
Yes, so that's what you would use a flow counter for. It's effectively like a tripwire, and every time someone passes it, it will increment the counter. And then those work in both directions. So it will differentiate between someone walking, across it left to right versus right to left. And those you just place them wherever you would please.
Okay. Another question here, is the price of obtaining pedestrian simulation based on square footage of the site with additional pricing variables depending on the other scope of work analysis that may be requested?
That's not a question I would know the answer to. I just build the models.
Fair enough.
But we can refer you to someone more qualified to discuss that.
Okay. And is it possible to create a situation in the software for the previous question with the truck lanes and employees?
I anticipate it would, but that would be probably a little bit more complicated than the average simulation. Just building those two things in together, that both the traffic and the pedestrians. But that's something that we would reach out to probably the developer to discuss further.
The developer of the software itself.
Yes, correct.
Got it. Okay. And I'm not seeing any other new questions here. Oh, is there technology where you can determine how long a specific person remains in an area?
Yes. Yeah. So, yeah, that's something you could do through code, for example. Have an area that when they walk into it, the time gets recorded, and then when they exit, that later time gets recorded, and take the difference between the two. And then that would just be saved onto a table and read. That's one way. Yeah. If it's an actual activity that they're doing, that gets automatically recorded. But if it's just kind of general them walking around a certain part of a building, that you would have to set up yourself. But that's incredibly trivial to do.
Oh, so it's very easy to do.
Yes, correct.
Cool.
Yeah.
Got another question about how to learn more details about the software. I can answer that for you. So after this webinar is concluded, everyone that is in attendance is going to receive a certificate and an email from a representative at PMC. At that time, we can issue you information about the software, and you're free to ask them questions. That would be the ideal time. One of the examples presented depicted light rail traffic, public transportation. So they would presume vehicle traffic is and should be a variable or touch point.
Yes, so there is rail transit. You can have that as something that just kind of moves through the area, but also something as a generation point or an exiting point for agents. That is in the software for things like rail and bus routes.
I'm not seeing any other new questions, but I do appreciate the in-depth questions here. This is very helpful.
Questions.
Yeah. But since we aren't receiving any new questions, I think we are good to conclude the call. So thank you guys for attending, and you'll hear from us soon. Thanks, guys.
Thank you, everyone.
Thank you.